Okay, good afternoon. It is March 26th, and yeah, had to answer a crap ton of emails this morning and talk to a whole bunch of students. Well, talk as in type messages and stuff. So, in any case, so what we're doing today is we're going to model with quadratic functions. We've done some solving. We've done some, factoring, and then using that to do some solving, and then we did some solving with the quadratic formula. And so we're going to put some of that into play today, quadratic formula especially. So anytime data forms a graph in the shape of a U or an N, a quadratic function might be the best way to model that data. And one of the, a common experience that we all have is the daily temperature from, let's say, 8 a.m. to 8 p.m. So if we kind of draw a little bit of a graph of that, and let's say we have 8 a.m. right here and 8 p.m. over here. And halfway between that is going to be 2 o'clock, 2 p.m. And let's say that we're talking about a day like today. So maybe the low temperature at 8 a.m. is like 35. And then we have 40, 45, 50. Maybe it'll get up to 50 today. And so we start here at 35. And a little later, it's a little higher. And it just gradually gets higher until maybe we take another temperature check at 2 o'clock. And here we are. And we take some more temperature checks. And we get down, back down to about 35 at 8 p.m. And so we can see that if we connected the dots here, more or less, using a parabola, we can see that we're we're going to get most of the dots onto our parabola. So a quadratic function is a great way to model something that has a peak. We have a low point, we have a peak, and then we have a low point again. Of course, we can flip that upside down, and we can talk about the stock market. Right before the virus, the stock market was really up high. I'm not going to use any data points here, any numbers, but we'll just use the concept. So here we are at the beginning of our situation, and then the virus hits, the stock market plummets, and then eventually, there'll be some bumps along the way here, but eventually in the long term, it will come back up. So that's just kind of another way to model what's going to happen with the stock market. Okay, so we have some modeling problems that I want to take a look at. And so let's talk about the first one right here, which I stole right out of the textbook, by the way. One of the things I like about this textbook author is he really does work very hard to find some good examples that are actually based in reality, based on real data and facts. And yeah, so here it is. So a woman's systolic blood pressure, P, at an age of A, is given by P equals 0.01 A squared. See, we're at quadratic here. Plus 0.05 A plus 107. So according to the model, what is the blood pressure at age 17? So this is our model, and remember, a model is like a weather report. It is our best guess based on data and numbers and formulas and equations like this that indicate what will be happening. So according to our model, which again is not perfect, what is the blood pressure going to be at age 17? So we're just going to plug 17 into here, and we'll get our answer. So somewhere I have a calculator, which I have, put it under this piece of paper right here. So I need to square 17, of course, and 17 to the second power is 289, which of course I knew. Then we're going to multiply that by 0.01, which gives us 2.89. And then we're going to add to that 0.05 times 17. And then we're going to add to that 107. And so we find out that the systolic blood pressure is 110.74. So again, just plugging in all the numbers here. So P equals 0.01, 17 squared, plus 0.05 times 17 plus 107 gives us, as I said, 110.74. 110.74. By by the way, that's actually millimeters of mercury, because back in the day, old school, they measured blood pressure by how much mercury displacement there was in a measuring device, and there it is, 110.74 millimeters of mercury. But that's not the way we do it anymore. We use our electronic blood pressure cuffs. So let's move on to the more difficult part of this, which is figuring out at what age is a woman's blood pressure going to be 115 millimeters of mercury. So blood pressure, that's going to go right there where the P is, and then we just need to figure out what the A is. And as I promised, this is going to be a quadratic formula issue. So we got 115 equals 0.01 A squared plus 0.05 A plus 107. So solving all quadratics, we need to zip this 115 over there. So we're going to have 0.01 A squared plus 0.05 A. 107 minus 115 is -8. Set that equal to 0. And so, of course, we're going to plug all this into the quadratic formula. And there's our A, there's our B, and there's our C. So we got -0.05 plus or minus B squared, so that's going to be 0.05 squared, minus 4 times A, which is 0.01, times C, which is -8. And all of that is divided by 2 times A, which in this case is 0.01. So I'm just going to jump right to 0.02 on that. So we got -0.05 plus or minus the square root of, so 0.05 squared is going to be 0.12325, right? 0.05 times 0.05. 5 times 5 is 25, and then we have 1, 2, 3, 4. You know, I really better check that. Maybe it's only 2 zeros. 0.05 to the second power. Yeah, it's 2 zeros. Yep, that didn't feel right. So, sorry, 2 zeros, 0.0025. Minus 4 times 0.01 times -8. So we're going to have -32, so -0.32. So minus a -0.32. All of that over 0.02. Just to make sure I'm correct on this. 32 times that, yeah, it's going to be 0.32. Okay, so then we're just going to add these two numbers right here. So we got -0.05 plus or minus the square root of 0.0025. So actually it's going to be 0.3225 over 0.02. And we got -0.05 plus or minus the square root of 0.3225. 0.3225 is 0.5679. 0.5679. All of that is over 0.02. And now we see here we're going to have two answers as usual. We're going to have -0.05 plus this divided by 0.02 and -0.05 minus this over 0.02. But we can see the second one of these is not really going to be very helpful because that's going to give us a negative answer for A, and A is age. So that's not going to make any sense. So what we're really going to do is we're going to do 0.5679 minus 0.05 is obviously going to be 0.5179 divided by 0.02. 0.5179 divided by 0.02 equals, and that's 25.895. Equals 25.895 years old. So, just an example of using the quadratic formula in this modeling situation right here. So, let's jump over and do a different question. And so, here's another common one here. We should remember this looking formula here from Algebra 2. So we got negative, so actually the formula, the general formula, is -16t squared plus v sub 0 t, right? The initial velocity times time plus the initial height. So the height of an object launched straight up from 7 feet with an initial velocity of 96 feet per second is modeled by, there it is, h equals negative 16t squared. This is our gravity bit right here, plus 96t. 96 is our initial velocity, plus 7. That's going to be our initial height. So that's 7 right there, right? All these things are right here in the formula. Negative 16t squared, always gravity. Gravity is always the same. V sub 0 is v at time 0 times t. And then h0 is h at time 0. So according to the model, what is the height of the object at 2 seconds? Well, that's easy enough. We're just going to plug in 2 here and here. So we're going to have h equals negative 16 times 2 squared plus 96 times 2. And you'll notice that I put parentheses around the 2 each time, just to kind of keep it all nice and clean. And a common error here is to multiply the 16 and the 2 first and then square it. Remember, order of operations, got to square first. So 2 squared, of course, is 4 times negative 16 is negative 64 plus, this is 96 times 2 is 180, 192. 192 plus 7. And so 192 minus 64 is 128 plus 7 is 135 feet. Easy enough. But again, here's where the difficulty comes in. When is the object going to be 50 feet above ground? So what I'm going to do is I'm going to actually have you do this one on your own. So the 50 feet, of course, is going to go right where the height is, right there. So it's going to be 50 equals this, and you're going to solve this using the quadratic formula. So please take a moment. As always, please really do this. This is where you do your push-ups. This is where you get strong. So pause the video, do the problem, 50 feet. Please do that right now. So I'm sure you enjoyed these fun numbers with the quadratic formula. So we have 50 equals negative 16t squared plus 96t plus 7. And so now we're going to just zip the 50 over there. So we're going to have negative 16t squared plus 96t equals, minus 43 equals 0, because 7 minus 50 is negative 43. So we're just going to put the numbers into the formula. So we're going to have negative 96. And again, you already did all this work, so I'm just kind of zipping right through here. So 96 squared minus 4 times negative 16 times negative 43. Not doing that in my head. Over negative 32. So we got negative 96 plus or minus the square root of, so 96 squared, that's 9216. And then we got 4 times 16 times negative 43 is 2752. All of that is over negative 32. And then we do 9216 plus 2752. So plus 9216, 9216 equals, and take the square root of that, and we have 109.4. I'm going to go with 109.4. So negative 96 plus or minus 109.4 over, that's 32, over negative 32. So you'll notice here that we have two options again. Negative 96 plus 109.4 divided by negative 32, which will get us a positive answer. And negative 96 minus 109.4 divided by negative 32, which will get us, again, another positive answer. So we'll do both of those. So we'll do 109.4 minus 96 equals, and then we're going to divide by negative 32. Divided by 32 equals, so 0.419. So we have equals 0.419, and we'll talk about that in a minute. And then we got 109.4 plus 96 and then divide that by 32. And we have 6.419. 6.419. And these, of course, are in seconds, right? Because this is all time, and time is in seconds. Okay, so what's really happening here is we have our ball being launched up into the air, whatever it is, from 7 feet, right here, 7 feet, goes up in the air, comes back down. And we want to know when is the object going to be 50 feet in the air, not drawn to scale, put 50 right there. And there we have our 2 times that the object is going to be 50 feet in the air. Oops, drawing off the paper here. And so we can see that this is where the first time is going to be, which is at 0.419 seconds, right there. And we have 6.419 seconds is right there. So these are our 2 times that the ball or object is going to be 50 feet in the air. So again, I just drew this. Here's my T right here, and here's my H. And we have 7 feet on the height. So we start at 7, we go up, and we come back down. And when is it going to be 50 feet? It's going to be 50 feet at these 2 times right here. 0.419 and 6.419. Okay, last modeling problem. So Bob the Builder is pretty hung up on Taylor Swift. Okay. He decides to build a small patio to hold a statue of her. He wants the length of the rectangular patio to be 2 more than the width, and he wants the area to be 22 because he's feeling 22. Anyway, what dimension should he use for the patio? So when we solve a problem like this, of course, we should draw a little diagram. And here's Bob's patio right here. And he wants the length to be 2 more than the width. So we'll make the width that, and we'll make the length that. And we know that the area is going to be 22. And we know that in order to find the area of a rectangle, we do base times height. So base times height, or w plus 2 times w, of course, is going to be w squared plus 2w. And that is going to equal 22. And we're going to subtract that over, and so we get w squared plus 2w minus 22 equals 0. So what we want to do, of course, is find out what is the width going to be, and then we'll have the length also. So we need to solve this. This is not factorable, as I promised. So into the quadratic formula it goes. So a is 1, b is 2, c is negative 22. So negative 2 plus or minus the square root of 2 squared, which is 4, minus 4 times 1 times negative 22. All that's over 2. And then we have negative 2 plus or minus the square root of 4 times 22 is 88. And that's going to be a negative 88. I'm sorry, it's going to be negative 88. So 4 minus negative 88 is 92. So we got a 92 right there, over 2. And then we just need to find the square root of 92. So square root of 92 is 9.59. So we have negative 2 plus or minus 9.59 over 2. And negative 2 minus 9.5 is going to be a negative number. Divided by 2 is still going to be negative, and that's not going to make a very good width. So we really only need to worry about the top piece right here. So negative 2 plus 9.59 is 7.59 divided by 2. And that's going to be 7.59 divided by 2 equals 3.795. So 3.795 feet. That's going to be the width. And then the length, of course, is going to be 2 more than that. So 5.795 feet. So there you go. Those are the 2 dimensions, the width and the length. So there you go. There's your lesson. And I'll have a small assignment for you, very small assignment. And hey, if you're not, if you are, here's the deal. I'm noticing that some people are just really not fully connecting here. So if you could reach out to your classmates and say, hey, let's get yourselves back together here and let's get it together. So if you could motivate your classmates, that would be awesome. So yeah, see you guys next week. Have a good weekend.